And let's have a look at the first question. We asked to find our x value so that this equation is equal. So we start from 2 to the power of x minus 1 equals to 64. Now, while we're dealing with exponential equations, one method that we can do is if we can turn the base into the same number, and then we can compare the power. Okay, that's one way to simplify that, because the x is in the power over there, right? So that will be a lot easier if we can compare the power. That'll be more like linear or quadratic equations that we can deal with. Okay, therefore we want to turn 64 into base 2 to the power of something, right? 64 is equals to 8 times 8. 8 is really 2 times 2 times 2. Therefore 64 is equals to 2 to the power of 6. If both sides are the same, and if they have the same base, then we can conclude the power must be equal. X minus 1 must equal to 6. And we can solve this, x equals to 7. Next question. For this one is the same. As we mentioned, it will be easier if we can turn everything into the same base. We have 3 and 3. We want to turn 9 into the same base. 9 is equals to 3 times 3. Therefore is 3 to the power of 2 times 3 to the power of x equals to 3 to the power of 5x plus 4. Just will remind you the index law over here. If you have two numbers timed together, they have the same base, and we're gonna add the power. That's precisely what we're seeing over here. Two numbers timed together, they have the same base, we're gonna add the power. So 3 to the power of 2 plus x equals to 3 to the power of 5x plus 4. Same thing as last question. If both sides are equal and they have the same base, their power must be the same. Therefore 2 plus x should be equals to 5x plus 4. Okay, let's solve that. Just move this around here so that we can have more space. Okay, when we're solving that, oops. Okay, we'll just move x to one side and then move number to the other side. I can see over here actually have more x, therefore I want to move that plus x to this side by minus x and minus x. And therefore we can move that plus 4 to the other side by minus 4 and minus 4. So you can see that's cancelled out and that's cancelled out. And that's give us 5x minus 1x, 4x equals to 2 minus 4, negative 2, x equals to negative 5. Next question. Same story, but they have the same base already. We're going to apply the same rule. If two numbers timed together, you're going to add the power. Brilliant. 7 just means 7 to the power of 1. Therefore, on the left-hand side, we should have 7, 1 plus 1 minus x. On the right-hand side, 7 to the power of 3, x squared. If they are equal, they have the same base, their power must be the same. Okay. Let's write down. 1 plus 1 is 2 minus x equals to 3x squared. Now we can see we have x squared. That's a quadratic. The way that we can solve quadratic is use double up. That's one of the methods. There's one thing. If you use double up, you have to move everything to one side and the other side is 0, right? Therefore, we're going to move this guy by plus x and move this guy by minus 2. So plus x and minus 2. And that's gone, and that's gone. Equation 3x squared plus x minus 2 equals 0. Let's use double up. 3x divided by 3 equals to 0. Two numbers timed together equals to a times c, which is negative 6. Add together equals to positive 1. Yes, this is going to be negative 2 and 3. Negative 2 and positive 3. We can see we can simplify this part because both actually contain 3. That's 3x minus 2 and x plus 1 equals 0. Therefore, x is equals to 2 over 3, or x equals to negative 1. Question C. Right, so we did mention about inequality in the class today. Let's have a look at how we deal with a question like this. 10 is not really an easy number to turn into base 2 to the power of something, right? Let's get rid of it. Well, since we have multiply, the way to get rid of multiply by 10 is divide by 10. Let's actually divide by 10 to both sides so that we can simplify that. Hence, on the left-hand side is 2 to the power of p minus 1. The sign's still the same because we divide the positive number. On the right-hand side is 16.5. Okay, based on the previous question, we already know when we're dealing with exponential equations or inequality, we want to turn everything into the same base. So, hold on, 16.5, that's not, we can't really turn 16.5 into base 2. But we can turn the number, it's pretty close to 16.5, which is 16 into base 2. That's base 2 to the power of 4. Okay, now let's think about this. If I can satisfy 2 to the power of p minus 1 less than equal than 16, that should be actually less than 16.5, right? We turn that inequality to something that we can handle, rather use calculator or other methods, right? Okay, now let's focus on this one. So 2 to the power of p minus 1 less than equal than 16 is really 2 to the power of 4. So 2 to the power of 4. Okay, although this is inequality, but same as equation, if they have the same base, then we can compare the power, right? So obviously on the right hand side is bigger, then this power must be bigger. Okay, so it says p minus 1 must be less than or equal than 4. Okay, same base, we can compare the power. Okay, how do we move that minus 1? Plus 1, plus 1. Both sides, it hasn't changed its sign. So p is less than or equal than 5. Okay. Next question over here. Same story basically, but there are different methods. But let's stick with the one we had before. This methods will work for basically all this sort of questions. We want to get rid of that the 9 first. Okay, just keep it simple. Otherwise, we have to turn everything into base 3. That's probably take too long. That's 30. You can't really turn it base 3. So why not just move the 9 to the other side so that that become one number. So we're going to divide both sides by 9. So we have 3 to the power of x minus 4, and that's still less because we divide by positive number. And 30 divided by 9 is really 10 out of 3, right? Roughly that's equals to 3.33 something recurring, right? Okay. I can't turn 3.33 something into 3 to the power of something. I don't really know how to do it. But I can find a number pretty close, which is 3. Okay, if I can satisfy 3 to the power of x minus 4 less than or equal than 3, this should be less than 3.33, right? So we're going to focus on the things that we can do. Now they have the same base. The power for that 3 is really 3 to the power 1. Therefore, the bigger number, the bigger the power, x minus 4 must be still less than or equal than 1. And get rid of that minus 4 by plus 4, which will have x less than or equal than 5. That's the answer. By the way, most of the questions that we addressed just now is merit and excellence questions. Okay, well done, guys. Let's keep going. Next question. Same story. If n is a whole number, for what value? And this. All right. Same story. We're going to move that times 6 to the other side so that it can turn into one number before we can judge anything on that. So 2. Let's divide by 6 to both sides, and to the power of n plus 1 bigger than. What is this going to be? Alright, you can figure out. I'll just slow down over here so you can see that's fitting twice. So you have 3 left. So 2.5. Yeah, 2.5 is right. Sorry, 20.5. Okay, so 20.5. 20.5. Great. All right, let's look for some number close to that I can turn into base 2 something, right? If I choose a smaller one, it's going to be 16. 16 is smaller than 20.5. And if I choose a big one, the next one, if I double 16, it's going to be 32. Because I'm looking for base 2, right? So hence a double. 16 is really to the power of 4. 32 is to the power of 5. Okay, so 20.5 is in between. That's fine. I do know n is a whole number, so that should be sufficient. Now, because this sign is bigger, therefore I want to choose a bigger number. I'm saying this, if 2n plus 1 is bigger, equal than 32, then must be bigger than 20.5. Yeah, it's pretty safe, right? Therefore, we're going to focus on this one. That gives us 2 to the power of n plus 1 bigger equal than 2 to the power of 5. Therefore, bigger the number, bigger the power. N plus 1 bigger equal than 5. Minus 1, n is bigger equal than 4.